Dear students, welcome to a new session. Today we'll be talking about geometry and we'll be talking about the concepts of circles. In this lesson, we're going to introduce the circle. The circle is what? The circle is a set of all points together in the same plane, and all these points are equal distance from the center point. The point in the center of the circle, we call it the center point. Okay. The point in the center of the circle, we call it the center point. And we name the circle with it. So if here we have point M is the center point, so we call it circle M. And point A is a point on the circle. And the distance between the center point and any point on the circle, we call it the radius. So the distance between the center point and any point on the circle, we call it the radius. And it has a label R. When we draw a circle, some points are inside the circle, some points are on the circle, and some points are outside the circle. As we can see here, the set of points that are inside the circle are points M, D, and E, where the set of points that are on the circle are like points A and B, which are the points that are on the frame of the circle. Where the set of points that are outside the circle, we call them as points X, Y, and Z. The surface of the circle is the set of all points that are inside the circle. The points that are in the region that is labeled by red color in here. What is the radius of the circle? As we said, the radius of the circle is a line segment with one endpoint at the center of the circle and the other endpoint is on the circle. The plural of radius is radii. The circle has infinite number of radii and they're all equal in length. Two circles are congruent if the radii are equal in length. Let's go to another terminology, which is the chord. What is the chord? The chord is a line segment whose endpoints are on the circle. Both endpoints are on the circle. Like here, as you can see it, it's segment AB. So here, segment AB is called a chord. What is the diameter? The diameter is a chord, but it must pass through the center point. So the diameter is chord BC. We call it a diameter because it's passing through the center point. And by the way, the diameter is the longest chord in the circle. Let's go to example 1. In each of the following figures, find the value of the used symbol in measuring. As you can see here, MA is a radius. MB is another radius. So these two radii are equal in length. As long as these two radii are equal in length, then MA is equal to MB. So measure of angle A is 40 degrees, as long as measure of angle B is also 40 degrees, because we know that if two sides in the triangle are equal in length, then their two opposite angles are also equal in measure. So the sum of measures of the angles in one triangle is 180 degrees. Angle A is 40, angle B is 40. So if you subtract 180 minus the sum of 40 and 40, so 180 minus 80 equals 100 degrees. So X equal to 100. Example B. If the external angle of the center is 220, and we know that the central angle is measured is 360 degrees as a circle. So the measure of the interior angle MBA equals 360 minus 220, which is 140 degrees. Then the question is asking you here to find the measure of angle A. Measure angle A and measure angle B are equal to each other. Then 180 minus 140 equals 40. If I divide them by the two equal angles, then each of these angles will be equal to 20 degrees. Let's move on. to another concept, which is the symmetry of a circle. Any straight line passes through the center of the circle, divides it into two identical parts. So the circle has infinite number of axes of symmetry. Now, let's go to the corollaries. The first corollary says that the straight line passing by the center of the circle and the midpoint of a chord, then it's automatically perpendicular to the chord. Let me explain it again. If we have a straight line, passes through the center and passing through the midpoint of a chord, then it is perpendicular to this chord. Another one, if a straight line passes through the center of a circle and is perpendicular to the chord, then it bisects this chord. If a straight line passes through the center of the circle and is perpendicular to any chord, then it bisects this chord. Says the perpendicular bisector of any chord of a circle, it automatically passes by the center of the circle. So if you have any perpendicular bisector to a chord, this means that any line that is perpendicular to a chord and at the same time it bisects this chord, bisects means cuts this chord into two equal parts, meaning passes through the midpoint of this chord. So if there is a line that is perpendicular bisector to a chord, then automatically this line passes through the center. Let us repeat them all quickly again. The first one says, if there's a straight line that passes through the center of the circle and also passes through the midpoint of a chord, then is perpendicular to this chord. The second one said, if a straight line passes through the center of the circle and is perpendicular to the chord, then it bisects this chord. Again, bisects means cut this chord into two equal parts. The third one, if there's a perpendicular bisector to a chord, then automatically it passes through the center of the circle. Let's go and check an example. In this example, it says D is a midpoint of segment AC, where E is also a midpoint of segment AB, and the measure of angle A equals 65 degrees. Find the measure of angle EMD. As you can see here, that MD passes through the center and D is a midpoint of AC. Then MD is perpendicular to AC. For the same thing, ME passes through the center and is a midpoint of AB. Then ME is perpendicular to AB. Then ME is perpendicular to AB. Then, as you can see here, that in quadrilateral EMDA, as you all know that the sum of measures of the angles inside the quadrilateral is 360 degrees, and we have angle MEA is 90 degrees, and angle MDA is another 90 degrees, then to find the measure of angle EMD, it's 360 minus the sum of 90 and 90 and 65. So it's 360 minus open bracket 90 plus 90 plus 65, and the result will be 115 degrees. Let's move to another example. In this example, it says that in the opposite figure, two concentric circles M. Concentric circles means two circles that they have the same center. And here the center is M. As you can see here, AB is a chord in the larger circle intersecting the smaller circle at C and D, where E is the midpoint of AB. The question is asking you to prove that AC is equal to BD. So there is a construction that we need to draw ME perpendicular to AB. How to prove that AC is equal to BD? In the larger circle, you will see that ME is perpendicular to AB. Then AE is equal to BE, because We just mentioned that if a line coming from the center and is perpendicular to a chord, then it bisects this chord. Accordingly, AE is equal to BE. For the smaller circle, ME is perpendicular to a new chord which is CD. Then CE is equal to DE. If you subtract equation 1 from equation 2, you will see that AC is equal to BD. If you subtract equation 2 from equation 1, you will see that AC is equal to BD, and this is what the question is asking us to prove. Now, we came to the end of our session. Thank you very much. Hope you enjoyed it, and see you next session.